Okay, we're going to carry on talking about Pythagoras' theorem here, and I'm going to talk about a very simple case. I'm going to draw it again in standard. I'm going to draw it a bit better. I'm going to draw it like that. And it's the simplest one of all, where that's 1 and that's 1, and I'm just going to call it x because we don't know what that x is yet. So let's write it out again. There's Pyth. Not drawing very well today. There we go. A, B, and C. And what we'll do is we'll substitute A, B, and C in from these guys later. A squared plus B squared equals C squared. So in this case, A equals 1 and B equals 1, because this side here is 1. So A here equals 1 and B equals 1 because it's up there. So what does that make this one here? Well, I've called it C here, but of course that's an x, isn't it? So I've called x squared equals 1 squared plus 1 squared, because I've got my two, that's the right angle there, I've got these two sides, A and B, both equal to 1. Well, 1 squared is just 1, plus another 1, and that's 2. So we've got x squared equals 2. So that tells us that x squared equals 2. So x equals the square root of 2. There it is. Let's see if we can get a handle on what that is numerically. So where's my calculator? Just a minute, I'm going to pause it here. Right, I paused it and I've found my calculator here. So what we're going to do is find out what the square root of 2 is. There it is, 2 square root. Here it is. Boink. Loads of decimal places there. And the square root of 2 is approximately equal to, I've lost it. Oh, here it is. Here it is. You can see here 1.4142 blah 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 blah. Well, I'm just going to forget about all these useless decimal places here, and I'm just going to work with the first 2 or 3. So it's 1.414 or thereabouts. Yes, it's probably worth pointing out that these digits carry on going on and on. It's like pi. It goes on forever and ever and ever and ever. It never stops. It never repeats itself either. This is a bit of a problem for Pythagoras, or at least Pythagoras' followers, who are kind of convinced that there should be a nice simple expression for this sort of thing. And the guy who discovered it, rather than saying, "Hey, that's an interesting problem," they were so annoyed by this that they took him out to sea and threw him overboard. So an early example of mathematics going a bit berserk there. Anyway, so x equals root 2 if it's a nice simple triangle. And I guess I'll keep on drawing it like this. 1, 1, root 2. It should be obvious to you. Well, I'm just going to talk about it. Let's just draw that triangle again. There it is. That side equals that side. They're both one unit. So I can sort of reflect it around here. And that's one side and that's one side. So we've got this root 2. It's the diagonal of a square. There's my square. 1, 1, 1, 1. They're all at right angles. Right angles. There they are. And the diagonal is root 2. And of course, because it's a square and everything's nice and sort of clean and right angled, both diagonals are root 2. Which is quite interesting, really. I just want to make another observation here, that this angle is a right angle. This angle here is 45 degrees. We kind of know that anyway, because that's a right angle in there, and we've cut that right angle into 2 symmetrical bits. You can see that this is a sort of line of symmetry here. So we've got the angles in this triangle are 90, because that's a right angle, 45, 45. And we'll come to this, we'll use this fact again and again, I guess, that the angles of a triangle add up to 180 degrees. The angles, the interior angles at least, add up to 180 degrees. And here we've got 90 plus 45 plus 45. Add all those together, 0 down, 1 to carry. 9, 10, 14, 15, 16, 17, 18. There you go. So they add up to 180 degrees. So There we go. It's a nice little piece of geometry, that. Before I forget, the the 45-degree triangle here has got an additional line of symmetry. If this line here that I'm drawing in these dots here, if that's a mirror, then you can see that we've got a nice symmetrical triangle, symmetrical about that axis there. So I can redraw it in non-standard form. I can draw it like this. It's supposed to be right angles. It's not very accurate, is it? It's not in standard format, and that's a line of symmetry, which is quite often useful. Okay, I'm going to stop there. Stop, stop, stop.